stimulate the insulin degranulation and exocytosis. So calcium here is kind of a must before insulin output takes place. This bar graph displays the increasing concentrations, the effects of the increasing concentrations of glucomalanga on the active insulin release in the pancreatic beta cells, and the presence of the submaximal stimulated concentrations of glucose. And in comparison to the control inhibitions, the glucomalanga could affect or could potentiate, I would say, this highly significant increase in the glucose-stimulated insulin release without any compromise on the cell integrity. This was further confirmed and evidenced via the calcium-free incubations, where comparable the alanine, which is the robust insulin secretagogue, the insulin releasing activity of glucomalanga was highly significantly abolished in the absence of extracellular calcium, and in the presence of the pharmacological inhibitors of the extracellular calcium uptake, namely verapamil and diazoxide, in comparison to the control incubations. Now, the plant could increase the insulin output from the highly depolarized cells in the presence of the maximal stimulated concentrations of glucose, and it could as well potentiate, I would say, synergistically the insulin release triggered by the oral hypoglycemic sulfonylureas, the terbitamide and the clofeniramide in comparison to the respective control treatments. So moving into the glucose transport studies as the first in line for the extra pancreatic studies, what we did in here is we used these slender T3 and 1 rat fibroblasts, and we differentiated them nicely into these roundish adipocytes, fat cells with dense cytoplasmic fat granules. In those cells, we carried out our glucose transport studies, and we could use them for the sake of the formulation of this sigmoidal curve, which illustrates the effects of increasing concentrations of insulin on the acute glucose transport in the T3 and 1 adipocytes. Out of it, out of this sigmoidal curve, we could extract two concentrations or functional concentrations of insulin. We would call this one the nanomolar, the submaximal, and the millimolar, the maximal, stimulated insulin concentrations with a broad activity window. Despite the fact that glucomalanga had no insulin-mimetic efficacies, but it could highly substantially potentiate the insulin-stimulated glucose transport in the 3T3 and 1 adipocytes. Moving into the enzymatic starch digestion studies, we did incubate the soluble starch with the alpha amylase and the increasing concentrations of glucomalanga. Then this was only followed by the second incubation with the alpha amyloglucosidase. Liberated glucose was evaluated using UV spectrophotometry. The robust classical drug in here is acarbose, which is very well, promoted for its dual inhibitory effects over on both enzymes, the amylase and the alpha-glucosidase. For our dismay and disappointment, unlike acarbose, none of the glucomalanga extracts could affect or exert any starch blockade effect. So we moved into the human insulin glycation studies. In this line of work, what we did is we used human insulin as the model peptide, incubated overnight with exceedingly high concentrations of glucose, namely 220 millimolar, which is quite, very, very high. And the monoglycated and the non-glycated insulin entities, they were separated and quantified using reverse phase high performance liquid chromatography. So what we were really interested in is getting this monoglycated insulin peak disappearing with the plant incubation, overnight plant incubation. And yes, similar to the aminoguanidine and comparable to its anti-glycation efficacies, the increasing concentrations of Cocomalanga could exert this highly substantial stepwise reduction in the human insulin glycation. So taken together, this study could evidence the novel multi-therapeutic efficacies of Cocomalanga in terms of the dual enhancement of the cellular pancreatic insulin secretion and the extrapancreatic glucose transportation, as well as the enhancement as well as the inhibition of the insulin glycation. These actions were on the water-soluble bioeffective being absorbed intact in the vapor. And all in all, these pharmacological appraisals, they may assess the use of Cocomalanga in providing new opportunities for the integrated combinatorial management, reversal and or prevention of obesity, diabetes. The proceedings of these investigations were actually published in the Journal of Experimental and Integrative Medicine. I'd like to take this opportunity to give my sincere gratitude for the University of Zaytuna for this opportunity to present these findings, and wishing the University all the very best in all its future endeavors. And thank you very much.
Thank you for the nice presentation, and if there is any question.
Thank you for your presentation. I have two questions for you. First, why did you choose this plan? Why did you choose this plan? And the second question, are you planning to go by in vivo study?
And he provided us this plant, but not only this plant. He provided us with other Indian plants. This is, mainly comes from the, the Indian subcontinent. And so we tested them all for these, battery of in vitro and in vivo assays. And I have the in vivo results, but they are still, the publication of this line of work is still in the pipeline. So what we did as well is not only, testing them individually, but we tested them in combinations. And the combinations, they proved even far more efficacious. Like the effects were more, the combinations were more potent than the any of the individual plants alone. So, like it's a massive, amount of results. So it's it's a matter of time before they are, inshallah, accepted the articles online.
Any other question?
Thank you. I would like to ask you if you, this plant, Cocomalanga, do they characterize the constituents of the plant, the chemical constituents, so you are suspecting certain group of compounds that are responsible for this activity or not?
Very nice, interesting questions, and it was among the questions we got from the review. But, who assigned us, granted us the acceptance eventually. Cocomalanga is extensively studied and extensively published. So why this article was through? Basically, what we did is the aqueous extract, not ethanol extract, not any other kind of solvent, in the process of extraction. And the cocomine is very well published as with a whole diversity of spectrum of activities. So I'm not coming up with something unusual, but the striking finding here is that the Cocomalanga lacked any starch blockade effect. Cocomine, highly surprisingly, was proven for its inhibitory effects on the amylase and glucosidase. But this one indeed was the crude aqueous extract, and like any other kind of extracts, and their incomparable effects. So maybe, and they provided as well action mechanisms like why curcumin is a very nice successful agent for the treatment of diabetes. This has provided some kind of an explanation that yes, curcuma is capable of releasing insulin, the same capacity as any like amino acid like alanine. And it is capable of doing this in a physiological manner, calcium-dependent manner, not by implementing any cytotoxic effect or action on the cells, causing the insulin leakage out of this. No. This was, and we could test that using neutron red assay, and no cytotoxicity was infected by the plant on the cells following the plant incubation. So there you go. We are quite we provided novel outcomes. Thank you very much.
Thank you very much. So we're going to move to the next speaker. So next speaker is Dr. Lama Hamadine. So she's assistant professor at Al-Zaytuna University, so this is our heart. She graduated from Faculty of Pharmacy, University of Jordan in 1999, and she was awarded her PhD in molecular medicine from University of Uttar Malaysia. She was awarded several medals for innovative research in her study. So she's going to be talking about a very important topic, not only in this country, but also in the world, the disorder of breast cancer molecular type among genetic. So,
thank you very much. First of all, I would like to welcome everyone to our meeting. And then breast cancer, which very gives most of our audience are females, and the rest we do have loved ones. And breast cancer is October is Breast Cancer Awareness Month, so we are moving towards personalized medicine. And then my goal is distribution of breast cancer medicine across among ordained patients. It's with partnership with St. Cancer Center. They provide us with samples of cigarette or some other stuff. Breast cancer is the most common cancer worldwide. In the United States, it's death rates are higher than immediate rates from the other types of cancer, besides lung cancer among population. So death rates and relapses are very important aspects in this. As a program, among protein, the last statistics in 2012, it records to number of cases in 2010. Breast cancer patients were more than 900 patients, accounting 93.6% of all tumors, and yet it is the most common cancer among ordained population. Patients diagnosed with breast cancer usually they got treatment plans according to their TNM classification, together with immunohistochemical classification to identify ER, and general status among those patients. Treatment outcomes usually vary among patients. 5 years survival rates would be highly affected by many genetic and environmental variations. Genetic variations are gaining a lot of importance in recent years. In 2009, a study working with many genes and gene expression in breast cancer identified a group of genes that they have importance in breast cancer development and outcome, by which bioinformatics was used, and then clusters of different gene subgrouping were identified among Caucasian population. And then softwares were developed, and then a group of tests called 50 tests to test for 50 genes that they are most important genes in breast cancer, were usually used to cluster patients according to different molecular subtypes. The objective of our study was to see if these molecular subtypes would again be applied to our ordained patients, because if with ethnic variation, there is any ethnic, or we can go together with these subgroups. These ethnic subtyping are very interested because they specify patients with 5 B, they have a more aggressive disease. Here, 2 overexpression, they have poor diagnosis. The new subclasses were basal-like and normal-like. Basal-like group of genes identify patients as a basal-like that they would have a just clinical behavior and then a high rate of metastasis and relapses. Normal-like, they are intermediate, they do have intermediate prognosis between dominant and basal-like, and studies show that patients they do not usually respond to neoadjuvant therapy. Gene expression studies are very expensive, so many studies they do try to link luminal A, luminal B, and subclasses with protein markers that they do in immune studies. So luminal A, luminal B, HER2, and triple negative patients could be classified simply by detecting the RTR, HER2, and 567 across proliferated markers. The objective of this study was, when we started in 2012, we wanted to investigate the best expression levels among Jordanian patients regarding these pathogens to see if we could be analyzing together with them, with patient populations. So we started with optimization with gene expression conditions using different test cases design, and then to classify patient samples from our patients, obtain for those patients who have 5 years past of their studies, so we chose patients from 2006 and 2007, and then we hope that they would be subclassed in the 5 intrinsic statistical groups. Up to the time of preparing this size, 102 samples were collected, 3 normal breast tissues were there. We wanted to correlate the outcome of the study with 5 years survival rate of patients. So patients underwent mastectomy or biopsy for breast tumor HCC in 2006-2007. We obtained their pharmacokinetics. Isolation of total RNA, cDNA synthesis, and then running some samples to reduce the number of our patients to control. Because paraffin-embedded tissues would degrade RNA, and the first RNA in many samples were degraded as long as we also conclude that the fact that these samples are quite old, and the conditions used to protect to process the samples were degrading RNA, and we accepted that, so 102 samples were reduced to control. But when we analyze, we optimize the conditions, then we take the gene expression of the samples. We ended up with clustering the patients in 6+ software in our package. There is an intrinsic, there is a part of the system software that we could include our data inside, and then they would correlate them with database that they have for application population. It is the data incorporated for European population. And if our samples were not fit in the system, then they wouldn't be clustered in this method. So we ended up by having clustering of patients and then distributing our patients into 5 subclusters. We do have most of our patients are basal-like 8%, 28% were nominal A. The images are not so good, much better. 28% for basal-like and nominal A. 16% were HER2, 15% were luminal-like, and 13% were normal. Actually, from these data, we cannot correlate anything, just the fact that our samples are quite similar with those in the training set for the patient population. So we fit in the same pathogens, which is a good point, because later on we can analyze our samples from patients, and then we can subcluster them to different intrinsic groups, and it would help us identify which treatment plan or which outcome we would expect from those patients that we are. Our future work will be to relate these molecular subtypes with the data representing protein profiles from ERPR 567 and a class of different protein expression in samples, and then from these samples we will link the gene expression of the protein levels, and then scale analysis of these molecular subtypes with the patient's bodies that are available. We hope to work with our partners at the HCC to see if there is an outcome from these studies to establish new plans for the patients, for that of their future patients would be undergo PAM50 tests, and then according to which subclass they are lying in, then we can identify which group of treatment or protocol of treatment would be better so that we can enhance survival. This work was funded by research grants from the university. We would like to thank the HCC, the college lab members for creating samples, and then all the work was done at our molecular lab at the Faculty of Pharmacy and the community. Thank you very much.
So it's open for discussion. So if you have any question.
Thank you, Dr. Lama. My question is, it is based on like experience from one of my friend's mother. She was suffering from breast cancer, and they asked her to do these genes mapping to help in the diagnosis and treatment. But unfortunately, we don't have these tests done here in Jordan. So they have, they do. Yes, they send it to the United States for gene mapping and stuff. We don't have this facility here in Jordan.
So that we can see the link of the patient and the relatives. But this work is different. This work is the gene expression in the patient in comparison with their normal cells. So we can subcluster them. So it's quite different.
I have a question. What's the frequency? I'm trying to understand breast cancer in the Middle East compared to the United States. I know you mentioned it's higher. Although we have, women, they go for check, like Mawad, she goes every year for checkup. But here, what's the same? Okay. So what's the frequency? Is like if there is any country in the Middle East higher in cancer or?
I can talk about breast cancer, not the others.
It's just breast, yeah.
We do have many patients phase alone, which is quite difficult. So the outcome of patient, I think we are not analyzing the data yet. The outcome of patient is quite not as good prognosis, not as the United States population. Then the median age is lower. So we do have 2 years because the average age. I think the United States